Namaste. Welcome to Canara Engineering College. Now we are at Makerspace for Innovation and Research at Canara Engineering College. This facility houses two funded projects. First one is funded by the Department of Science and Technology, New Delhi, and it is on plastic recycling technology. The second project is on building an electric vehicle retrofit. This project is funded by Kapu Muralidhar Shenoy, a NRI from United States of America. This facility was recently inaugurated by Shri G. Pradeep Pai, Managing Director of Hangyo Ice Creams Private Limited. In this facility, till now, 20 engineering students have done their project work on different aspects of plastic recycling. At the same time, over 500 students from high schools and PU students have visited this facility under creating awareness on plastic recycling. Plastic recycling involves 4 steps. First step is called agglomeration. In this, plastic film, something like this, are being densified and converted into agglomerates, something like this one. In the second step, these agglomerates go into this machine called extruder. They are heated over here to higher temperature and converted into filaments, something like this one. These hot filaments are then cooled in water bath, first of all, and then secondly, they are cooled in air, and finally, they are cut into smaller pieces using a granulator over there. So this is the total process of recycling the plastic into industry required material. I am Dr. B. Krishna Prabhu, Principal Investigator for both these funded projects.
Hi everyone, I am Vinod Kumar MB, Assistant Professor from Mechanical Engineering Department as well as the Co-Principal Investigator of the DST funded project. Right now I am going to explain the plastic processing unit which is located at Canara Engineering College. So initially the plastic waste what we get in this particular form is fed into this particular machine which is called as agglomerator. In this agglomerator, grinding of the plastic takes place. Inside this, there are few blades. Once the plastic is particularly fed into this agglomerator, the plastic gets grinded using 10 blades which is located inside it, in which 4 are rotating and 6 are stationary. And the product that we get out from this is called as agglomerates. It will be in this particular form as we see. These are agglomerates. So this is the material that I feed into this machine and the product that I get will be in this particular form which is called as agglomerates. Moving on, this agglomerates has to be fed into the extruder and from there it will be extruded and the final granules are obtained. So we will moving on to the extruder. The agglomerates is fed into the extruder and this is the hopper part of the extruder and the agglomerates is fed over here. From here, these agglomerates pass through the extruder and extruder there is compression happening and there is a screw inside it and heating chambers are there. What happens is when this particular sample is fed, the sample is getting heated and slowly it gets melted and gets compressed and it comes out from this particular die in the form of small filaments as we see over here. This filament is then water cooled in a cooling chamber and it passes from here using this particular conveyor, and here after water cooling what we do is air cooling. For that we have the fans which are used for air cooling it. The water contents are removed from there and then it passes from here and it finally reaches the granulator. After air cooling, the filaments are passed to remove the water content using air cooling and then it is passed into this particular machine which is called as a granulator. In the granulator, the filaments are cut into small granules which is also called as dana. So here we have a roller as well as a cutter and it rotates at a very high speed and chops it into small pieces which is called as granules. And this particular granule is the raw material that is used by industries for further converting it into any of the finished products.
Greetings of the day. I am Saviraj Anandur, Junior Research Fellow under DST funded project. What you are seeing now is a compression molding machine of 20 tons capacity. The granules which is obtained from the granulator is molded in the die of required form using excessive heat and pressure to make the final products which are economically and ecologically sustainable. This paver block, which is developed from 90% recycled plastic and 10% Tetra Pak waste, is 3 times lighter in weight than conventional concrete block and 4 times more in strength. We have a 3D printer in our laboratory which is used for carrying out research on developing alternate filaments for 3D printing. 3D printing is a modern technology of manufacturing which, unlike conventional subtractive manufacturing, has many benefits like lesser manufacturing time. We can make intricate and complicated products easily and almost zero wastage. This beautiful idol of Lord Ganesha is made from our 3D printer using plastic filaments. You can observe the beautiful and intricate carvings on this.